Welcome to this presentation from Spatial. We're going to take a little look at our products and particularly water systems for the capture and editing and maintenance of that. Just before I do that, the company itself, Spatial, is a software and services company. We focused primarily on the geospatial engineering solutions and bridge the gap between CAD and GIS. We've been doing that for 18 years or so. And we really look at not reinventing the wheel, but using industry standards and building out solutions for utilities and based on engineering best practices. We do consulting services and managed services as needed. And taking a look, our head office is in Australia. We have a North America and South African office. We started in 1994, and you can see when the other offices were established. We're certified and partners with a number of different organizations. If we look at our solutions, we have Munsys, which is what I'll be showing you today. It is our editing tool. It's powerful editing inside of AutoCAD, but in essence allows you to build a structured, intelligent utility model of your data, but using CAD. We have Enlighten, which is our web-based geoportal, which publishes that data live on the web. We have another product called ACDC, which allows for the automatic validation and loading of as-built submittals before they even get taken into your organization. So that when they have passed a validation ahead of time, you know that you'll be able to load them directly into your GIS and or CMMS system. We also have a field map solution, which is a cloud and mobile GIS application platform for mobile users. Looking at the architecture of Munsys specifically, Munsys works as an application on top of your AutoCAD products. If you know AutoCAD, you already know 80% of Munsys, and it's very easy to train you. What Munsys does, and that's what each of these vertical fingers is provide an application. In the case of water, you would have the menus, the icons, the business rules in an application on top of AutoCAD, but drawing the data from a single central database. And I'll just expand on that a little more as I show you how the system works. Moving on from that, on the administrative side, we have tools for doing management of users, feature classes, attributes, such that we have essentially what we call our DBA, database administrator, in a box, such that you can manage your Oracle database without necessarily being an Oracle expert. On the right is the distribution and reporting. That's where our Enlighten product, our GeoPortal, fits in, as well as a number of other integrations that tie in for distribution and reporting of the same data from a single source of truth. We use open data standards, so our tables, our data formats are all completely industry standard and open and can be accessed by a simple database connection from any other system. Number of customers in North America, we've got campuses, we've got counties, we've got cities. All of them really are dealing with utilities and building that out. City and County of San Francisco, Sacramento, Solano County, water agencies, a number of campuses, Michigan State, Notre Dame, Boulder, etc. Let's look at Munsys per se. This is editing in AutoCAD. It's essentially CAD on steroids because in effect the data on your screen looks like CAD, but it's now actual GIS data in a database, spatially located with attributes. And if it's a utility, it's usually a connected, modeling ready, attributed data set. We store the data in the single central database, which allows for us to enable multiple editors to simultaneously work on the data. This is huge in organizations because you don't have what we call sneakernet, where you have to run around and go find out who's got the latest copy of a particular CAD drawing and when they changed it and what they changed, etc. We provide off-the-shelf applications and data models, water, sewer, storm, roads, electrical, cadastral, for example. Those include their own menus, their own business rules, the feature classes and attributes that go with those, with domain or lookup values and to ensure that data is consistent, tools for doing data integrity checking, and powerful attribute editing tools. I'll show you a couple of those in our presentation. Just let's step back. Data is the single most important part of any kind of asset management. Just knowing where your information is, that's the foundation upon which everything else ties in. You have different kinds of data. You have new data, stuff coming in. You need a workflow to load that. You need to track what's happening. You have existing data. How certain are you of the quality or completeness, and how does it get updated, and who gets to use that information? A lot of places have this, and I'll just run through how we go from this to an attributed and intelligent data set. When I say this, I mean data that's in paper plans, in red lines, or in CAD drawings, or in map books. If you have CAD drawings, so these paper documents, paper-based documents, have their own benefits and disadvantages, and I'll touch on how we deal with those. Also, CAD drawings. You may have CAD data. This is a CAD drawing, and it has a number of issues on it. Things that are snapped, lines that are literally drawn to allow space for where the text goes. So there's really no connection and no length intelligence in that data set. Here's a storm data set with the pipe coming from nowhere. Is it going out there, coming in there? What does it connect with? How will you model with that? Or symbols that break the lines, and the line snaps to the edge of the symbol. So this pipe has no idea that it connects through to those ones. Or even more importantly are attributes where there's ID numbers or diameter, and this is a chilled water supply or chilled water return, or there's things like invert elevations as text next to or near or at a leader line on any given data set. That's a problem, because if you need to do a report, what's the total length of lines of this diameter in this area or across your entire system, how are you going to do it from data like this? And that's where you really want to build this out. The other thing is that the data is typically in your system coming in from CAD, and so the people who know the data are CAD people. The people who use the information are engineers. And there's usually a big workflow problem between engineers and CAD data and GIS folks who are really there for doing analysis and modeling, whereas the folks in the engineering side are more detail oriented. They typically, you need to marry these workflows and these skill sets, because CAD is by far and away the dominant source of the original data, but also a very, very powerful tool for drawing and capturing data. And that's where Munsys comes in. So let's just look, for example, at this. Next step, a lot of paper information scanned. Here's a set of folders with projects in them, and each of the projects may be one PDF or individual TIFF files. And let me show you what we do with those. We take, say, this plan view here, and we literally pull it into the map by using the Munsys features. If you look at this is Munsys on top of AutoCAD. You can see the menu here is a Munsys menu, whereas the environment is CAD. So application in CAD. Here is insert the image, that'll put it there. And then you can use the geo reference image tool, which says give me 2 points on this image and locate them where that box is, so that now you've put it in its place. We then create a geoscan boundary. That would be this actual line there, and on that the tool automatically pulls out the folder path, the name of the file, and you can then enter the project number, etc. And now you have essentially a polygon where that particular sheet is. You can do the same for projects. And that's useful for two things. One, it's obviously useful for heads-up digitizing, meaning you can zoom in and go capture stuff, any sort of pipes. I think these are sewer pipes, but there's drainage, water, and any number of richness of data in these plans, and so you could use that. More importantly, well, equally importantly, is you can also use that as a spatial index, literally a set of postage stamps, so you can go anywhere in the map in future and say, what do I have on the record as plans in this area? In this screen, still in Munsys, so still in AutoCAD, I select a box where that red outline is, just to show you where we're at, and say give me all plans that intersect with that area. And what I've got is a colored up set returned to me of red squares which are the sewer category plans, and black squares, which all of each of those outlines a page for a plan, the black ones being drainage. So here's a list then of all of those referenced. So at 3 clicks of a button, I can go in, show the area, get a list, and run down any one of those plans and projects. That's very useful because now each of these postage stamp index, the spatial index of plans, gives me a very powerful tool. Of course, you can use that in our browser-based product, Enlighten. Here's the same data, the same area, where I've literally drawn a box there and it's selected all of the plans. You can, it's in a web browser, so there's a hyperlink you can just open up by clicking on that, or you can drill down to get a list. Here's a list of those plans. Click on that particular one, here's the link and more detail of the project number, date, page, etc. And on that individual link you can click on that and it'll open it up in the browser right there for you to look at. Very powerful tools for just managing those as-built data. Let's look a little more at the CAD data. So here's Munsys and CAD data. I'm going to just walk you through a few examples. We're going to look at some real life situations. Here's a CAD drawing. Actually, I have this one live. I'll show it to you. And we're going to have shown you how it turns into Munsys data. Looks the same. Very powerful, subtle differences, and particularly around attributes and connectivity. See this line here is a CAD polyline, and it's not broken where this line intersects. So this pipe, there would be some sort of fitting there. You see this hydrant? Obviously someone exploded the block, and now it's actually a polyline with 2 other little line segments for the pumper connections. The text is just text. This hydrant has no idea that it's a fire hydrant 10 in this instance. When you move into Munsys, on this side, the line you can see is actually got a fitting, it's broken, it's separated out. This is one object, so that number 10 relates to this. This 10 inches is the diameter of this pipe, and it's driven by the diameter value on the pipe, the attribute. In CAD drawings you get this stuff where it's confusing. Is that a 6-inch water or a 10-inch water? So we don't really know. Run it down, it was in fact a 10-inch. Anything in Munsys over here, you can then also have the added attributions. So all of these are columns in a table. There's the 10-inch, and we don't know the pipe material yet, but we do know it's a distribution main, so you could fill that in. The start and end node has been calculated. It has an ID, and so you can, and the water category is potable. So now we can do things like, well, give me the length of lines that are potable and 10 inches in this data set or this area, etc. Well, let's show that to you in live, real world live action. So here's Munsys. Looks like AutoCAD. Has a command line, it's got menus and icons, etc. This is an as-built submitted, and once again illustrates the challenges of a CAD drawing. So if I zoom in over here, this is a CAD drawing of all sorts of different utilities for a subdivision. So here's a pipe. The valve obviously doesn't break the pipe, and you would need that. It's snapped to the outside point of that, not the insert point of the hydrant in this case. If you look at these lines, they're just drawn so that they look okay. There's no connectivity or snapping along there. How do you know what the diameter of this pipe is? It's just not here. It's not on the layer name. It's difficult to know. So you'd have to take a look. It doesn't actually show you on this plan. On other ones, it has it somewhere near as text, and you'd have to pick that up from there. So that's just information. So Munsys allows you to take this data and convert it into attributed information. Let's look at another drawing. Let's go to this one. So this is the CAD drawing I had a screenshot of. You can see it's a CAD line. It goes all the way along there. You can see this hydrant here. That valve is not broken. In fact, it's not even a block. It's a polyline. You can see the pipe just sort of stops and starts any old where. Challenges inside of the drawing. Everything's labeled with leader lines, so that 10-inch really has nothing to do with this. There's sometimes data inside the layer. So here we take that layer name, we pull out the 10 DW for domestic water main, and we assign that as an attribute into Munsys. So we pull that in. Also, this is not located in the real world. So we've gone in and taken that information and pulled it into the Munsys drawing. So this is Munsys, and at any time inside of Munsys you can come in and let's just say we're in this area here. I'm just going to remove these. Well, actually, let's go here. So here's that same data converted into Munsys. So we've pulled out the 10 inches and we've put that as an attribute, 10 inch. It's created a start and end node. So you can draw those things and take CAD drawings, convert them directly into this, like here. Completed that line. You see it goes from a fitting there to a fitting there. That's been split. The hydrant, if I go and click on the hydrant number, there it is. It's right there. And so we have in there that it's a hydrant. We know what its name is. That's its reference number. This 10 inches comes directly from the pipe. There it is, 10 inches. So if I change the pipe diameter, I can go there. And the difference between CAD and Munsys is that this is actually a line in a table. So if I go here to get a little technical, there's the table name. This is a line that has 4 vertices, 1 segment. It's not locked and it's not modified. So this is a multi-user system where you can edit and change information. So if I wanted to, for example, change the pipe diameter, I could simply go in, click on a pipe, and I could do, let's click on a couple of them, let's say all of these here. Here is an edit dialog, and this is really where the power starts coming in. As you can see, you start having tools for building out data sets, and very easy to use. So most things are on drop-down lists, so if you wanted to change that diameter to something else, you could. You can change the category. You'll notice that I'm editing simultaneously. If I turn that off, I can auto zoom to one object at a time to move that out the way, and just so I can see I'm editing that guy there, and I can move along to the next pipe. And so you can easily go in, edit your data. You can check for integrity checks to see that it's snapped. We'll check that that's there. We'll actually flag the errors and allow you to build those out. So that's just taking enabling a CAD operator to work in a much more powerful fashion. The data itself lives in a database. Say I wanted data in this particular area, I could go in and set my area of interest right there. And to load information in, I literally go in and say, all right, give me the water pipes nodes. These each are tables within the data set. So if I go in and run that, it's now pulled those in. If I hit F2, you can see there's pipes retrieved, nodes retrieved. It's literally pulled those out the database. And so I can go in and use that. So you have things on different layers. You can set all of that up. So just a quick introduction to the Munsys product. It is a multi-user editing platform for building connected attributed data sets, and you can use that using underlays. You can use it at any time. You can turn on aerial photos, that sort of information, and very powerful tool for data capture. So let's go in then and finish up on the PowerPoint. So there's that image, by the way. So that then is the Munsys product. Each module, like if you learned water, it'd take you about a day and you'd be up and running and learning water. So it just shows you there's a pipe, attributes, editing tools. To get a little technical, within Munsys there are specific data tables for point, line, polygon and text features, and they have attributes in them, data columns if you like. You then pull things into your current drawing using a query, and that allows you to filter, which is good for analysis. You could say, oh, only load pipes that are larger than 8 inches or whatever, or pipes within 300 feet of this spot. So that allows you to set there. The application gives you specific menus and functionality, and if you look at that, and I should have shown you, but if you go and look on the menu, there's things like to do the editing. There's extend and break pipe. So that will automatically break the pipe and create 2 new attributes, carry over all the attributes within the data set. So if I come in here and I need to draw a new pipe on here, so all of the menus, there's settings. You can draw a pipe. Let's say I draw a pipe from here to there. I didn't snap it in on that one, but then I could use the tools to say this is currently one pipe from there to there. I could come in and say, you know what, I need to extend and break pipe. So it says select the water pipe to break very easily. So we select this guy, and there's the pipe to extend. And now it's created 2 new segments and automatically done that. So it just works like CAD. That's the same way you do an extend and break in CAD. Show the subject and then do the change. And you'll notice that it's carried over these things in asterisk, so all the characteristics of the original pipe. So it just does a powerful job of building out those data sets. Let's go back to the PowerPoint. Well, I thought I was going back to the PowerPoint. There we go. And in the drawing you can set everything: layers, colors, line weights, layouts, and for printing and plotting, anything that you can do in AutoCAD like that, that uses that. So it really is a powerful tool for that. That was a brief introduction to Munsys and to using Munsys for water data. Thank you.